Well, now that we've finished our discussion of systems of linear equations, we're going to take a look at systems of linear inequalities. But let's review first. Way back in Chapter 1, we remember that a linear equation can be written in many ways. One of the ways is, this would be called the general form, ax plus by equals c. And then the one you mostly remember is this one, slope-intercept form, y equals mx plus b. The number m is the slope, and the number b is the y-intercept. And then we have the point-slope form for the equation of a line. Y minus y1 is equal to m times x minus x1. M is the slope, and the ordered pair x1, y1 is just any point that is on the line. So let's do one example of each of them. We could say 2x minus 3y equals 5. That'd be an example for number 1. A slope-intercept form could be y equals negative 1/2 x plus 2. And then the point-slope form, we could write y minus 3 equals 1/2 times x plus 4. And what that means is that the slope of the line is 1/2, and one of the points that is on the line would be x1, y1, which would be negative 4, positive 3. All right, well now let's take a look at an inequality. Well, before we look at the inequality, let's first graph a linear equation. And the question is, what is the solution to a linear equation? That's just every single ordered pair that is on the graph of the line. Every single one of the infinitely many points. So let's do this example. Graph the linear equation y equals 3 over 2x minus 3. Well, this is in slope-intercept form. The slope is 3/2. Maybe I'll write that down. And the y-intercept is negative 3. So let's plot that y-intercept. Here's the origin, so that's the y-intercept. And now the way I'll graph the rest of the line is I just need to get one more point. So I can take, from this point, I can use the slope. Remember, it's rise over run, so I can rise 3 and run 2. Go up 3 and over 2. And I could do it again, up 3 over 2, like that. So I'm going to draw a line. That's the graph of the line. Now notice I put the arrows on it because it goes on infinitely in both of these directions. And notice this is just a portion of the xy plane. The xy plane is actually infinite as well, going in all directions. So notice what happens here. This line divided the xy plane into two what we call half planes. We've got this half plane, and we've got this half plane. And we call this one the upper half plane, and we call this one below the line the lower half plane. So I'll refer to the upper half plane as UHP and the lower half plane as LHP. So if I were shading the upper half plane, I might do something like this. And I'll write upper half plane. Notice I need to use arrows because it goes infinitely in that direction. And the lower half plane, maybe I'll use a different color. The lower half plane is this direction. So notice what we have when we plot a line. Every single point in the xy plane is either on that line or in its upper half plane or in its lower half plane. So for each point xy in the upper half plane, what can we say about x in relationship to y? Well, every point on this line satisfies this. The y value is exactly equal to 3 over 2 times x minus 3. Well, suppose the y value is greater than 3 over 2x minus 3. That point would be in the upper half plane. Suppose the y value is less than 3 over 2x minus 3, then it would be in the lower half plane. So one of those three conditions has to exist. So for each point in the upper half plane, we know that y is greater than 3 over 2x minus 3. So all I did is take the linear equation and change the x into a greater than. Remember, we think of y as being the height of the function. Y is the upness and downness, while x is the leftness and rightness. So the height of the function is the value y, and if it's taller, greater than 3 over 2x minus 3, we know it's above the line. And likewise, for each point in this lower half plane, I'll use the same color green, we know that y is less than 3 over 2x minus 3. Okay, and before we continue, let's just write down all of the possibilities for a linear inequality written in our slope-intercept form, similar to this. Well, every linear inequality could be written like y is less than mx plus b, or y is less than or equal mx plus b, or y is greater than mx plus b, or y is greater than equal mx plus b.